All right, this next lesson is about factoring. We've already talked about two different types of factoring, and now this goes further into it. One of the first things you need to be very familiar with is you always factor out the GCF first. Always, always, always. So whenever you're asked to factor, you always look for the GCF first. And then after you do that, you need to factor even more. Okay, it's kind of like reducing a fraction. Sometimes we divide by 2 to reduce the fraction, and then sometimes we have to reduce it again, divide by 2 again, or divide by 3 again, or something like that to keep reducing it. Well, this factoring means you keep factoring until you can't factor anymore. So let's look at this first example. Well, I have a trinomial, and this polynomial right here, I have to factor out. It says to factor, and that's what we want to do. It's very first you look for what is common between those. Well, first, remember the first step is you look at your numbers, and what's common between the numbers? Well, I see a 3. A 3 is common with all those. And then look at your x's, and what's common between all of those? Well, 1x is common. So your GCF is 3x. So remember, this is your GCF. And what you're going to do with that is you're basically going to divide each of these by 3x. Again, you just do this mentally. You don't have to actually show the division of that. And so what remains, if you divide this first one by 3x, what remains is x squared. What remains on this one is 5x. And then what remains on the last one is minus 6. Now, so we factored out the GCF. Now, after that, this trinomial can be factored more. You still have the GCF out there. So now what we need to do is look at just what we did in the last lesson. You look at this last term and find what two numbers that multiply together to give you negative 6. Well, negative 6 could be negative 6 times 1. It could be 6 times negative 1. It could be 3 times negative 2. It also could be negative 3 times 2. And so it's one of those possibilities, but then you find which one actually adds together to give me positive 5, and it's this guy right there. So x plus 6, and then x minus 1. So all of this is your answer, including the GCF. So the way to check this is if I multiplied all that back together, then it would equal the original problem. So all of this, if I multiply back together, equals that. And that's what factoring is. You factor the GCF first, and then you factor all the way until it can't be factored anymore. Let's look at some more examples. So this one right here, again, first look at the trinomial and see, can it be factored? The GCF, is there anything common with that? Well, I see a 5. So we're going to factor out a 5. So we're going to divide each of those by 5, and I have x squared minus 7x plus 10. I divided each of them by 5. And then can it be factored more? You still have the GCF out there. Well, again, this is x times x, and then you look for two numbers that multiply together to give you this, but also adds together to give you that. Well, let's first look at the multiplying. Well, it could be 10 times 1, it could be 5 times 2, but also remember, it could also be negative 10 times negative 1, it could also be negative 5 times negative 2. And you're trying to find out which one adds together to give you the middle number, and it's this guy right here. So minus 5, minus 2. And again, the order does not make a difference. So all of that is your answer, again, including the GCF. So let's try one more. What's common between all three of those? I see a 6. I also see an x. So divide each of them by 6x. So you're going to get x squared plus 5x plus 4. And what we're going to do is factor even further. Don't forget the GCF is still there. And again, notice what two numbers multiply to give you the 4, and then which one of those adds together to give you 5. And you should be able to list them out, but you should be able to do some of these in your head. So that's plus 4 plus 1. 4 times 1 is 4. 4 plus 1 is 5. And again, the way to check all that is to actually multiply it all back together, and that right there will give you this. So you would actually FOIL this, if you're checking it, you would FOIL that and then multiply everything by 6x. That's how you would check it. All right, let's take factoring to another step. So what if I had this and you start looking at this and you say, well, there is nothing in common. There is no GCF. Now notice there's something different about these factoring problems. Notice all the problems I've given you in the past to factor. All of them always had a 1 in front of the x squared. A 1 in front of the x squared. So if it has a 1 in front of it, then you can do that little process. You know, you find two numbers that multiply together, give you that, and add together, give you 5. If it has a 1 in front of it. All right, so now notice this does not have a 1. So what we're going to do is it's a different method. This is called factor by grouping. Some books or websites call it the AC method. And the reason why, because here's a polynomial, ax squared plus bx plus c. And so what we're going to do is, it's called the AC method, because to get started on this, we're going to look at the a and the c. So in this problem, the a and the c is 6 and 4. So you multiply those together, so you know AC, a times c, is actually 24 in this problem, 6 times 4. And so you start thinking of all the multiples of 24, you know, that multiply together. Well, it could be 24 times 1, it could be 12 times 2, it could be 8 times 3, and it could be 6 times 4 to be able to get to 24. And again, it could all be, don't forget all the negatives as well. So, but everything in this polynomial is positive, so I'm not even going to list all the negatives because it's not even a possibility. Now, what we need to do is, you still do this sort of the same thing. You still find out, you know, which one adds together to give me the middle number, and it's 8 times 3. Now, here's where you got to do something different. So the 8 and the 3, what we're going to do is we're going to rewrite this. But instead of writing the middle term, we're going to actually use these two numbers, 8x plus 3x. And we're going to, notice 8x and 3x add together to be 11. So we're not changing the problem. We're just, it looks like we're making the problem longer because we went from 3 terms, now we went to 4 terms. But there is a reason why we're doing this, and we're going to factor by grouping. And by the way, just so you know, these two middle terms, it does not make a difference which order you put them in. So if you put 3x first and then 8x, it does not make a difference. You'll still get the same answer to be able to do that. So matter of fact, let me show you. We're going to get the same exact answer. So let me rewrite this. All right, so what we're going to do is we're going to factor by grouping. So grouping, literally, it has 4 terms, so we're going to look at the first 2 terms. So just mentally group these together, and mentally group those together. Okay, just mentally. Don't really put parentheses around them, okay, but just mentally group them in your head. So look at the first 2 terms, and let me underline these by purple, and I will underline these by blue. So look at the purple ones, and then you factor this. Like, what is common between 6x squared plus 8x? Well, what's common is a 2x. And then you factor that out, and divide each of them by 2x, and what's left is 3x plus 4. Now look at the blue ones. What's common between the blue ones? Well, I don't see anything common except for maybe a 1. So let's divide each of them by 1. So the 1 is common. You always factor out something, by the way. And so you divide each of them by 1, you're left with 3x plus 4. Now the cool thing about factor by grouping, notice these match, and they will always match. Hint, hint, they will always match. So what we're going to do is notice those, and we're going to factor that out. Remember, factoring is you factor out the GCF. What's common between those are those highlights. So if you factor out a 3x plus 4, well, what remains is 2x plus 1. And that is my answer. So if I FOIL this back together, it would give me my original problem. All right, so let me show you, because again, I'm going to do that same problem, but I want to show you the exact same thing. It did not make a difference if I wrote 3x first or 8x. So you factor by grouping, so you look at the first two terms, factor out what's common is a 3x, and you're left with 2x plus 1. And look at the next two terms. What's common between those is a 4, and you factor that out, and what remains is 2x plus 1. And notice these will always match, always match. So what's common is a 2x plus 1, and notice what remains is a 3x plus 4. Notice that's the exact same answers I got. So when you find these numbers right here, it does not make a difference which order you put them in. That's what I wanted to show you. The two middle terms, it did not make a difference what order I put them in. All right, so let's try this one right here. Again, what I want you to notice, very first thing you always do is factor out anything common. So what do you have in common here? Well, I notice there's a 2 in common between all of those. So if I factor a 2 out, I get 10x squared plus 17x plus 3. Now, can it be factored more? Well, yes, and notice this first number is not a 1, so we're going to have to factor by grouping, or use, it's also called the AC method. So you're going to multiply the A and the C, and that's 30. So AC equals 30. And again, think of all the multiples of 30. So 30 times 1, 15 times 2, 10 times 3, and then 6 times 5. And again, you could list all the negatives as well, but everything in this problem is positive, so I don't have to worry about any negatives. Now, only one of these adds together to give me 17, and that's 15 times 2. And so I'm going to rewrite this as 15x and 2x. Again, the order does not make a difference. It does not make a difference whatsoever, so I'm just going to write the 2x first, and then the 15x. And again, you still have the 2 outside. All right, you still have the 2 outside. So, matter of fact, just so I'm going to remember that later. I'm just not going to write it right now. So at the very end answer, I'm going to have a 2 out here. Okay, so just don't forget the 2. That was the original GCF, and so that is part of the problem. So let me just focus on factoring this. So I'm going to look at factor by grouping. Is I'm going to look at the first 2. Factor what's common. Well, what's common is a 2x, and then you factor out a 2x. So divide the first one by 2x, and you're left with 5x. Divide this one by 2x, I'm left with 1. Now I'm going to factor out, look at the next 2. Factor by grouping. So what's common between those is a 3. So factor of 3 out. Factor again means divide. You divide the first one by 3, and you're left with 5x. Divide the next one by 3, and you're left with 1. And again, I want to say it again. These will always match. Okay, always match. If they don't match, that means you made a mistake. Okay, they have to match. So what's common is a 5x plus 1. So that's what I have highlighted. I highlighted 5x plus 1, and then what remains is 2x plus 3. So all of this, including your GCF, the 2, is part of your answer. And again, the way to check that is actually FOIL these 2 back together, and then multiply everything by positive 2, and it will be the original answer. And that's another lesson on factoring.